Hi, I'm Sujay, and I'll be presenting our work on the generalizability and predictability of recommender systems. This is joint work with Duncan, Jonathan, John, and Colin. For various computer vision and language tasks, using pre-trained models is commonplace nowadays. On the other hand, for recommender systems, despite being widely used, the literature on reusing models or automating model selection is lacking. Many RecZilla models are optimized keeping a specific dataset in mind. This motivates our large-scale study of recommender system approaches, where we compare 18 algorithms and 100 hyperparameter sets across 85 datasets and 315 metrics. First, we assess whether RecZilla algorithms are generalizable, and then whether RecZilla algorithms are predictable. So are RecZilla algorithms generalizable? That is, if an algorithm performs well on one dataset, will it perform well on another dataset? From our results, what we find is that all algorithms perform well on some datasets and poorly on others. The table here shows the mean, minimum, and maximum ranking of all 18 algorithms over all datasets. Nearly all algorithms are ranked first on at least one dataset. The only exception is random, which has a minimum rank of 2. This shows us that algorithms do not generalize well across datasets. Next, we study, are RecZilla algorithms predictable? That is, given a metric, can various dataset meta features be used to predict the performance of RecZilla algorithms? The table here shows the meta features that are most highly correlated with the performance of each algorithm. In this table, we are specifically looking at the performance on the precision at 10 metric. Several meta features are highly correlated with algorithm performance. For example, one of the simplest metrics, the mean of the item rating count distribution, is highly correlated with performance of two RecZilla algorithms. This tells us that various meta features of the dataset can be used to predict the performance of RecZilla algorithms. Motivated by these findings, we introduce RecZilla, a meta-learning based algorithm selection approach. At the core, given a performance metric and an unseen dataset, RecZilla first computes nearly 380 meta features to characterize the dataset. And then, based on these meta features, it predicts the best algorithm and hyperparameters for this unseen dataset. Here is a block diagram of the RecZilla framework. We use the results from the large set of experiments as a meta-training dataset for our meta-learner. In the first stage, given a user-specified performance metric, we train a meta model that predicts the performance of each of the set of algorithms and hyperparameters on a dataset by using meta features of that dataset. At eval time, given a new unseen dataset, we compute the meta features of the dataset and then use the meta model to predict the performance of each algorithm. And then, based on the user selected performance metric, we return the best algorithm. In conclusion, we conduct the first large-scale study of recommender system approaches comparing 18 algorithms and 100 sets of hyperparameters across 85 datasets and 315 metrics. We show that for a fixed performance metric, the best algorithm and hyperparameters highly depend on the dataset. We also show that several dataset meta features are predictive of algorithm performance. Based on these findings, we create RecZilla, the first metric-independent and hyperparameter-aware algorithm selection approach to recommender systems. We release our code and several pre-trained RecZilla models in our repository. In addition to this, we also release the raw data from our experiments for researchers to build their own RecZilla models. For more results, please refer to our full paper. Thank you.